Hi everyone, myself Padmashri. I am pursuing third year in SVCE. Let us know the topic of converting NFA to DFA with an example. Firstly, we need to know what is a DFA. DFA refers to an deterministic finite automata. A finite automata of FA is said to be n deterministic correspondingly, where NFA refers to the non-deterministic finite automata. In this session, I am going to explain this example with complete explanation. Let's see the example. Like we have three queues like Q0, Q1 and Q2 and all are interconnected with the directions. First we have to write the transition table where the state and 0 and 1 and the level of states like Q0, Q1 and Q2 and address where the Q0 is passing the value 0. The Q0 is passing the value by itself, so we have to write the value as Q0 and check Q0 sending 1 to Q1 and also to Q2. There are two directions where Q0 is sending to Q1 and Q2 as a value of 1. So write down the both values and next go for Q1 and check where the Q1 is sending 0. Q1 is sending 0 for itself and also to Q2. There are two directions which the Q1 is sending 0 and next check the Q1 value for Q1. Q1 is sending one value for the Q2. Write down the Q2 and next value goes to Q2. Q2 where you have to check where the Q2 is sending 0 to the next value. Like it is sending 0 to Q0 and Q2 is sending 0 to Q0 and Q1 too. So write down the both values and check Q2 for 1. Q2 is sending 1 for Q1, write down. By writing this, we can complete the transition table. After completion of transition table, step 1 is to consider the value Q0 for the first state. Like state of Q0 comma 0 is equals to Q0 itself, where Q0 sending 0 as value for Q0 itself and check for Q0 by applying 1. Like Q0 is sending value as Q1 and Q2. It is sending value 1 as 1 as for two states. Like here comes a new state which has been not recognized in the transition table. Hence it is considered as a new state for the next iteration. Like next check for the Q1 state. Let's write down the Q1 state and apply 0 and check whether Q1 is sending 0 for any other states. Like it is sending 0 for Q1 and Q2. Write down the state and which is also represented as a new state in the previous state itself. Hence only one state is considering and check Q1 for Q1 for 1. Q1 is sending value Q2 for already. So it is also present in the previous transition table. So no need to mention it as a new state and check for Q2 again. Q2 is sending 0 for both two states where Q0 and Q1 and Q2 is sending 1 for Q2. Okay, where we got a new state here of Q1 and Q2, write down the Q1 and Q2 value and apply and check. Q1 is sending 0 for Q1 and Q2 and Q2 is sending 0 for Q0 and Q1. Here combines Q0 and Q1 and Q2 which forms a new state which is not represented in the table. And check Q1 and Q2 for applying 1. Like Q1 is sending the value Q2 for by applying 1 and Q1 is like Q2 is sending the value 1 Q1. Here comes the value Q1 and Q2 which is a new state which already we have been solved. By solving the state, it retains the same state. Hence, a new state should be continued for the next iteration. check for Q0 and Q1 and Q2 by applying 0. Q0 0, Q1 0, Q2 0. Q0 applying 0 for Q value 0, Q2. Q1 by applying 0, it retains an Q1 and Q2 state, and Q2 by applying 0, it retains a Q0 and Q1 state. Here, therefore, it retains the same previous state as in question. And check for 1. Q0 for 1, Q1 for 1 and Q2 for 1. By applying Q0 for 1, like we have Q1 and Q2. By applying Q1 as 1, we got Q2 and Q2 for Q1. Here comes the value Q1 and Q2, which is already been checked by in the above state. Hence, carry out the new state which has been find out in this third iteration of Q2, which is a new state. We have to check that state by applying Q0 0, Q1 0. Q0 is sending the value Q0 itself and Q1 is sending the value Q1 and Q2. And therefore, it retains the value Q0, Q1 and Q2 and check for Q0, 1 for Q0 and Q1 as a new state. Q0 and Q0 comma 1 and Q1 comma 1. Q0 is sending a value 1 for Q1 and Q2 and Q1 is sending the value as Q2. Here we retain the Q1 and Q2 state. By after completing all the iterations, we didn't find any new state. So write down the transition table again by looking the previous solved question. Like the all three states remains the same as we didn't have any new or extra state, and by performing this new state Q0 and Q1, we got the values of for Q0 and Q1 by applying 0, we got the value Q0, Q1 and Q2, which has to be written here, and by applying 1, we got a value of Q1 and Q2, which has to be written in the state of 1, which completes this state, and check for other state which we have Q1 and Q2, which was the first new state which we got in the Q1 state. Like by applying 0, we got the value Q0, Q1 and Q2. By applying 1, we got the value Q1 and Q2. We have to write down the same values, and Q0 and Q1 and Q2 also a new state which we have performed by applying 0 and 1. We got the same retained states which been previously written. We have to completely write down the transition table again, and we have to start drawing the diagram. Like Q0 remains the same for 0, but Q0 sending 1 for the value Q1 and Q2, and Q1 is sending 0 to Q1 and Q2, and Q1 is sending 1 for Q2 itself. Hence, we have to connect directly by making it as Q1 and Q2, and Q2 is sending 0 for Q0 and Q1, 0 for Q0 and Q1, and Q2 is sending 1 for Q1. And after Q0 and Q1 is sending 0 for Q0 and Q1 for Q2, and Q0 and Q1 is sending 1 for Q1 and Q2, and Q1 is sending 0 for Q0, Q1, Q2, and Q1 is sending 1 by itself, so it is a self loop, and Q0, Q1, Q2 sending 0 for itself and it is a self loop, and Q0, Q1, Q2 is sending 1 to Q1 and Q2. Hence, we have converted a Nfa to Dfa. Thank you.